all for being here. Welcome to Verify AI's webinar series. I'm really excited to be here today to introduce to all of you our two fabulous interns, Ronilo Ragodos, who's in University of Iowa doing his PhD, and Ethan Ho, who's a senior at UC Berkeley. So the purpose of this webinar is for Ronilo and Ethan to share their thoughts on data science and machine learning, sort of give you guys a perspective of how they chose this line and what they like about it and how they got into this field. Right? So I think we've got a pretty good turnout. I see a lot of young people in our audience. So part of the webinar, a part of their talk is catered towards encouraging the next generation to get into data science. I think both Ethan and Ronilo will share their experiences and their perspective. So let me introduce you to Ronilo Ragodos, Ronilo was born in Hawaii, Oahu. And at the age of 10, he moved stateside with his family, moved to Texas. And Ronilo did an undergraduate in mathematics and computer science from Texas A&M. And then he didn't get enough of math, so he went to University of Iowa and did a master's in math. And now he's pursuing a PhD at the University of Iowa. Ronilo loves playing the guitar. He's a music aficionado, and he loves watching crime series on TV. And one of his guilty pleasures, he told me, is watching reality TV, which is interesting to say the least, Ronilo. And then we've got Ethan Ho. Ethan, again, has a fabulous international background, just like Ronilo. Ethan grew up in South Africa and spent, till the age of 13, he was in South Africa, and then moved to California. And Ethan is an avid sportsman. He was, playing soccer at Palo Alto. The other thing about Ethan is he's climbed Mount Kilimanjaro. Okay, this is 19,000 feet and one of the tallest mountains in Africa. And Ethan, when he's not coding and studying, he loves to play soccer, right? So Ethan is currently a senior at UC Berkeley, and he'll talk about his plans as well. So without further ado, I'm going to hand it over to Ronilo.
Okay. Mic works?
Yeah.
Okay. Hi, everyone. As Sandeep mentioned, I'm Ronilo, and I'll sort of talk about my path to getting into ML and what I'm interested in the field of ML, what those things are, and how they can be applied. So you can do next slide. So my academic background, I think, might be of interest because one thing I wondered when I was younger is what classes and majors should I have in order to reach my desired career path. The two things I want to hit hard, I think, with this presentation is probably the most useful things for, I guess, high school students interested in ML to take would be AP Calc and Stats classes. And if you have it, AP Comp Sci. So I think those are the most important in high school for me, certainly the ones I most enjoyed, which led me to further explore math at Texas A&M in my undergrad. So I did computer science first and then added applied math as a double major halfway through because I believed it would be important later. I went on to do my master's at University of Iowa, and early on got involved with a professor doing interpretable machine learning, which I'll talk about later in my other slides. And in my master's, I think the most important classes were the ones of the analysis sequence, which is basically all of the extensions of calculus. And finally, currently, I'm doing my PhD at University of Iowa in the business analytics department, and I'm still doing interpretable ML with the same professor from my master's, and we're focusing on reinforcement learning, which I'll talk about later. And important classes for grad school would be optimization and probability theory, which are sort of further generalizations of stats and calculus. Next slide. So here's the timeline. I started in 7th grade going to these summer schools subsidized by my city government to get the children in my city interested in engineering. And we went to those every summer for 4 years, starting in 7th grade. And every week we would have presenters come and talk about their jobs or experiences. These people were from academia or industry. And once in the 3rd year, someone came to talk to us about Java and Python and how he knew young kids like our age that were making a lot of money making mobile apps. And so that's sort of what got me interested in programming. So I started teaching myself Python at that time, and I sort of naturally got introduced to AI, which led me to take AI classes at the summer school and in my undergrad. And then specifically in undergrad, sort of a high-profile researcher came to present to one of my courses about GANs, which are a really nice thing about machine learning that you can use to create artificial images, like take in images of animals and make new images of animals that don't exist but look convincing. That sort of caused me to become interested in machine learning in particular. Before, I was just interested in computer science theory. And then, as I mentioned before, once I got into grad school, I started working on machine learning itself. Next slide. So let's talk about what machine learning is for those of you maybe in high school. So I think the best way to explain what ML is it's just applied stat. So ML is really applied math. It's you cannot do it without math. So the best things, as I mentioned before, for you to do to prepare for especially a research career in machine learning would be to take AP Stats, AP and BC Calc if you have it, AP Comp Sci if you have it, and definitely get started teaching yourself programming early. I think that one is really important. I think the culture of my undergrad was to do a lot of self-teaching. So as for what machine learning is, we differentiate it from traditional programming by thinking about the difference between the inputs and outputs. So traditional programming gives or needs very specific instructions to give deterministic outputs, whereas machine learning will give you a function and you don't need to give specific instructions. The function will sort of automate that for you. So we can further divide machine learning into 3 sort of big subfields, which I'll describe as follows. So supervised learning is what you use to learn from old data and predict things about new data. Unsupervised learning is when you learn patterns from unlabeled data. So this is sort of just an automatic process. And reinforcement learning is a newer field that's different than the other 2, which were sort of traditional, where you have a program that learns from environmental stimuli to do actions which you tell it are good or bad. And by sort of learning over time what things are good, it can learn to do tasks that you specify. And I'll talk about that in much more detail in another slide. Next one. What interests me in ML inside of these subfields? So as I mentioned, machine learning can be divided into 3 fields and then further distilled into many, many subfields. So my primary interest, like many people in ML, is in general AI, which is human level AI. And then, as I mentioned before, interpretable ML, ML which explains itself, which I'll talk about. I'll talk about all of these actually. Fair ML, ML which addresses biases. This is one modern problem, I think, which is coming up more and more. Ethan will also talk about this one. Reinforcement learning, ML which learns like a baby. which is why I think it's the most interesting field and most likely to lead us toward general AI. So I mentioned general AI is my main interest. RL, reinforcement learning, is what I believe to be the closest thing we have right now toward a framework toward general AI. And then finally, real life application. So you take all of the above ones and apply it to real life. Next slide. So interpretable ML is my main research area. This is machine learning that can be divided into two parts. Ordinary machine learning just has what we call a black box. You give it some data and it outputs what it thinks about that data. So for example, a black box model that predicts whether somebody would go for a hike would just take in data about that person and perhaps the weather, and then output a prediction about whether or not they'll go for a hike. Interpretable ML might provide instead a tree diagram like the one you see in the picture. So it automatically gives you the reasoning behind why it makes a prediction. So if you give it information about the weather, it might say you'll go for a hike depending on the wind and the rain. So it's much better for business applications and people who actually care about why and how the machine learning model is doing what it does. The second type of interpretable model is one which takes a black box model and uses it to create something like a tree diagram like you see below. These are often less reliable, but they're still nice to have because oftentimes black box models are more accurate than interpretable ones. And this is something that's the main thing we deal with in interpretable machine learning. Next slide. Next one is fair ML. The story behind this one that I like to tell is going off of this software called Compass that was used by United States judges to rate how likely someone being tried for a crime was to commit another crime. The term for this is recidivism. But an independent news organization analyzed the software and found a bias. So what they found is that it was twice as likely for Black people than for white people to incorrectly predict that someone would go on to commit another crime. So it would say Black people were high-risk individuals to commit another crime, but in reality they wouldn't do it. And it would do that twice as often as for white people. So this is something that stirred the ML community and got everybody more interested in fixing this problem. And then another one, very, very recently, is the pulse algorithm, which took in very pixelized images of people and then upscaled them into HD images. But quickly after it was published, people found that this one also had a bias. So it would take in pixelized pictures of Black people and then turn them into white people. So you can see the image below. It took a picture of the former President Obama and turned it into a white man. And so this is another sort of display of how and why it's important that we in the ML community ensure that we minimize and mitigate bias and lack of fairness in our algorithms, because these things are hugely important to society, and we need to make sure that we're not doing anything harmful. Next slide. Next, reinforcement learning. As I mentioned before, this is something that you can think of as a baby. So you tell the baby, here's a reward if you do something good. And hopefully the baby learns to, do what you want it to do. The modern use for this is in video game AI and self-driving cars and robots and healthcare. And Sandeep, can you click the link? The link you'll see below is an application of reinforcement learning where the researchers were trying to teach a model of a body to run. So they just made a model of limbs and muscles and gave it no information about walking and running and told it to go from point A to point B and hope that it eventually learns how to do that. So in this framework, you have what we'll call the agent, is that model of the body. And we have an environment, which is, of course, everything you see around it. And then you have a goal, which is to get from point A to point B. And you give the agent a reward every time it actually gets from point A to point B. And it turns out that using reinforcement learning, we can train the computer to actually figure out how to walk by saying it's good if you get from point A to point B. Eventually, it'll learn the most efficient ways to get from point A to point B, which of course means it learns how to walk and run, which I think that's just amazing. But yeah, if you're interested in this video, you can just look up reinforcement learning how to walk, and you can watch the rest of it. Next slide. Finally, I'll talk about some business applications that we do here at Verify. Business applications meaning machine learning applications in business, and I've divided them by the type of machine learning. So first we have classification. So this is where we can classify the quality of computer chip designs. So even before they're physically built and just designed, we can predict how good they're going to be when they're designed by using information about previously built computer chips. Then there's clustering, which is unsupervised learning. This is something we use to automatically group the computer chip designs by their quality. There's also time series forecasting, which is where we take data about the past and predict what's going to happen in the future. One of the most important contemporary issues, of course, is the coronavirus, and time series forecasting is something we can use to predict how it's going to behave in the future. So we can predict how the number of cases or the number of deaths will rise or fall in the coming days and months with using time series forecasting. And then finally, reinforcement learning. This is something we can use to find bugs in computer chips and also to do stock trading. So it's to maximize your profits by figuring out how much money to invest in various stocks and when to buy and sell and so on. So these are all things that we do at Verify using machine learning. So it's just sort of a sample of how you can use machine learning in the real world. These are the ones that I've worked on personally. Ethan will talk about others. So I'll leave it open for questions and then we can move on to Ethan's presentation. So yes, please let me know if you have any questions.
Thank you, Ronilo. That was fascinating. Your journey has been fantastic. Thank you for sharing. I'll start off with a question, and for those of you who want to ask a question, if you could go to the Zoom tab which says participants, and if you click on that, it brings up this list of participants, and then you can raise your hand. And once you raise your hand, we'll allow you to unmute yourself, and then please ask questions. And the more the questions, the better, right? So Ronilo, a few things that struck me. One is interpretable machine learning. That's like a big word. Is there a simpler word for this field if people want to understand more about it?
Is there a simpler word? I don't believe so.
How about explainable AI or explainable machine learning?
That works too.
That works too? Okay.
Yeah.
Okay, great. So my second question is, how did you end up in doing a PhD in business school rather than following your passion for math or computer science?
Well, sort of one of my goals along the way in undergrad was I believed math was the main gateway to anybody doing any sort of science. And so my philosophy was, the more math you know, the better you'll be as any kind of scientist. And so I wanted to do as much math as possible. to prepare me for whatever I decided to do in the realm of computer science or machine learning.
That's great.
And sort of the logical conclusion to that was, of course, finding my PhD advisor in math grad school in machine learning.
That's fantastic. So one follow-on question before I open it up is do you feel there are many, many business problems that can be solved using machine learning? Just like in engineering and scientific problems?
Yeah, definitely. There's a lot of money to be made, a lot of business problems to be solved. I think business school is a good place to be for machine learning, if not in a computer science program.
Okay, that's great. Thank you for sharing that. Guys, I know you have questions, so please raise your hand. Okay. Okay. Ethan's got a question. Go ahead, Ethan.
Thanks for presenting, Ronilo. I was just curious as to, with all this academic background that you have, what, like you said, there were many possible domains that machine learning could be applied in. What specific domain do you currently find most interesting in terms of exploring different ML techniques and avenues you would want to pursue further?
I think the most interesting one that I'm currently wanting to focus on is the self-driving task. So for those of you who don't know how Tesla's self-driving AI works, this one works using reinforcement learning. So probably the most interesting application of machine learning and reinforcement learning to me right now is self-driving. Others that I haven't explored yet, but I want to, are using ML in physics and astronomy.
That's great. Okay, so Ethan, welcome. Take it away.
Thanks for having me. I'm actually pretty excited to present. I guess before I dive into my presentation, I just want to preface that my presentation is more going to talk about kind of my personal journey into data science, why I got into it, and just the several I consider milestones that have happened within the past like 2 or 3 years, and how that has shaped my perspective now and what I would recommend for other high school students who might find anything from my story particularly interesting. Yeah, so I guess, like Sandeep said, I moved from South Africa to California for high school, and I attended Palo Alto High School, like I'm assuming many of the high school students in this chat attended. And the one class that kind of had that kind of aha moment for me was also AP Statistics, but not because it was easy, by no means. I actually got like a B in the class, and it was one of the hardest classes I took. I couldn't really understand the mathematical concepts behind it, but I still found, the numbers and the data particularly interesting. And so that kind of led to me pursuing a major in data science and industrial engineering in college. And now that I'm approaching my senior year, I currently have no postgrad plans, unlike Ronilo, who has a master's and PhD. So yeah, next slide, please. So I guess this is an overview of what my presentation is going to look like. I'm going to talk about one specific instance in high school that kind of shaped my perspective on stats and why I got interested in it. And then my first internship while in college with a startup in Palo Alto as well, with a company called DocAI, and I was working on mental health predictions, which I'll get into later. And then this past semester, I studied abroad in Singapore, and that kind of also helped shape my experience. And then fast forward to now this summer, where I've been working at Verify, making an interpretable AI chatbot. And then in the next semester, I plan to not attend school. Next slide, please. So yeah, I think in high school, at least in this Palo Alto district, there's this kind of this notion that, you know, to get into a good college, you have to take as many AP classes as possible, take, you know, the hardest classes that are out there. And this was very challenging to me because I wasn't too good at math and, you know, I wasn't too good at classes, but I still wanted to challenge myself. And so one of the biggest issues I found with the kind of class schedule was that, you know, the class description didn't really say anything or provide any insights into how hard the classes truly would be. So me and my friends found out that at the time, the Palo Alto School District had all the classes on public display. And so essentially we just requested for all the classes. So we got like, I was honestly surprised that we could get this, but like all the grades, all the homework scores, all the test scores of all the students. And we essentially compiled all this coursework onto a website that, you know, didn't contain any complex machine learning or AI for that matter, but just like means and standard deviations of, you know, the average test scores in a certain class. And our kind of goal was to make students have more informed decisions on their classes. Next slide, please. Yeah, so during this process, we use things like this box plot on the left, right? So if you look at this box plot, this could be for the same class, and this might show that, you know, fifth period class had higher test average, had 85% as compared to the second period. You know, maybe this is because the teacher is more energized after lunch break and is teaching better, or, you know, maybe the students in fifth period class are just overall smarter, you know, and these types of insights we found was, you know, you wouldn't be able to tell from the course catalogs. So, you know, we concatenated all this information and we were able to discover that, you know, data uncovers hidden insights, and this allowed us to kind of provide a resource for the rest of the high school students. One particular thing that I'm still proud of today was that we would send out these random surveys to students to compile, you know, how much time they think that they spend on homework. And we basically constructed a homework time calculator and put it on the website. So some student could put in all the classes he plans to take, you know, maybe that'd be 7 APs, and it would come out to be like 40 hours of homework a week. And so, you know, I thought that was kind of cool. Next slide, please. So yeah, that was my high school journey, and that kind of kicked off my pursuit of data and thinking about how data can overall help people and find solutions that otherwise wouldn't be. And so in my next internship, I worked at DocAI, and they have this thing called Serenity, which is the female person on the left. And Serenity essentially is like this female or AI chatbot in which you would, you know, send it texts about your day. You'd be like, "Hi Serenity, today, you know, I slept 10 hours and I'm feeling a little tired." And Serenity would respond with certain resources that might guide a person to, you know, maybe get better sleep, like maybe try meditation or work out. And so kind of the goal for this was to have an interpersonal AI chatbot that directed people to resources. And my particular project was to somehow detect when a person would be, you know, quote unquote depressed. So obviously that's a very general term, and there was a lot of kind of backroom discussion on what that meant and, you know, what it took for someone to actually be classified as depressed. Next slide, please. So the overall process that I uptook was this thing called natural language processing, NLP for short. And so essentially what this does is it transposes like a sentence into words. So for example, on the right, like if someone said, "I feel happy because of your positivity, what got you feeling good?" And the person responded, "You know, mom had a birthday party." Somehow the machine would have to make sense of what "mom had a birthday party" even means. You know, how does a machine know what that is before it can decide if someone is depressed or not. So one of the core things about NLP is this process called tokenization and word embeddings. And so essentially what this means is that it deconstructs the sentence, like mom had a birthday party, first into separate words, like mom had a birthday party, and then somehow made that into a set of numbers that the machine can understand. And so in the next slide, I'll kind of explain at a high level what that looks like. So one of the, I know there are many high school students out there, and all this jargon might not make sense to you, but the main high level thing I want you guys to kind of get from this is that the words turn into numbers. And so what the machine tries to differentiate is what do the different words mean in relation to each other, and how does like king differ from queen. So in this example, this kind of algorithm is called word to vec, and essentially it takes a word and puts it into a bunch of numbers, which essentially turns out to be a vector, and they graph it on some 2D space or 3D space or whatever you have. And so in this graph, you can see that they have like a king vector and a man vector, and then a queen vector and a woman vector. And if you check out the lines between king and man, you get some distance. And so essentially what this tells you is that, the difference between king and man is captured between the difference between queen and woman, right? So then king to man is what queen to woman is. And so just that kind of notion and distance mathematically is how a computer is able to, at a very high glance, differentiate the meanings behind the different meanings between the two words. Next slide, please. Yep, so segueing into what I use for the machine learning chatbot at DocAI and at Verify is this thing called BERT and Albert. And so Google, I think like 2 years ago, released this huge NLP model, which like in the previous slide, you saw that was just 4 words. But what Google did is they took 2.5 billion words on Wikipedia and trained a model on all those words. And I think some 100 billion books. And so you can just imagine this huge corpus of text data that this machine is, finally able to understand. And so this essentially unlocks like a realm of different possibilities in terms of understanding, for a computer to understand what words mean. And so some of the applications might look like, a chatbot or text generation, or even voice activation or voice data sets, right? Because they transpose voice into text, and then text is then analyzed. And so in the next few slides, I'll kind of explain at a very high level what this meant. Next slide, please. Yeah, so this is a fun little fact that, just to showcase one of the simple applications of BERT. And what I essentially did was fed this paragraph about how photosynthesis works into BERT, and then try to see if BERT could answer these 3 questions, like what is photosynthesis? How does photosynthesis work? And why are plants and algae important for Earth? And if you read I'll give you guys maybe like 10 seconds to read the paragraph, just briefly to try see if you guys can figure out the answers. So this is essentially like you could theoretically pass in your whole biology textbook, and but could potentially do your homework for you depending if it answered the questions right. Next slide, please. You guessed it. BERT actually got it right, and so when you asked it for what is photosynthesis, it was able to understand what that was and how to identify that in the paragraph. And so it responded with the process through which plants, algae, and some bacteria use the sun's energy to create organic matter. BERT doesn't understand what that sentence means, but it knows that that's the answer of what is photosynthesis. And likewise, it answered 2 and 3 not as thoroughly, but answered it nonetheless. Next slide, please. Yep, now transitioning into kind of my project area of focus at Verify, I was working on a chatbot as well, like the one in Doc.ai, but this one was to leverage a model very similar to BERT, which is called Albert. And essentially what we did was we took this Albert and we turned it into a chatbot to answer queries about a model. So here at Verify, we work with hardware engineers who train, like thousands of models on hardware verification, which then they get all these model results and accuracies and, all this type of data that in order to find out what it is, they have to write some code, like, to query the model about the accuracy. And so what we did was that we made it so that that engineer, instead of writing code, he could write a simple sentence like, what is the model accuracy? And doing it that way, we're able to query the model through Albert. So, which is pretty cool because now any person can find out stuff about their model without having to write any code. Next slide, please. Yeah, and just another cool illustration about, so something about BERT and Albert is that both of these things are trained on these things called transformers. And another model that was also trained by this was GPT-3. And the function of GPT-3 was that it took in, 100 billion words, and, it has all this understanding, but its goal is to generate text. So on the left, you see that this person took GPT-3, fed it in an author's name, and just the first word, it. And the rest of the poem was all generated by a computer. And, if you read it, it's really hard to tell between the difference if the author actually wrote that or the computer. And so this again unlocks a realm of possibilities in terms of, automating a lot of work that a human might have done, but now maybe a computer could have done. But something that needs to be stressed is that with this amount of power, a lot of people can abuse it if put in the wrong hands. And, something like what Ronilo said about fair ML. And if you look at the right picture, you see that someone fed in the words Jews, Black, woman, and Holocaust. And some of the phrases that GPT-3 came up with were very, disrespectful and harmful and, racist. And so you can just imagine that, any person who's, running shady websites or fake news or any of these things can use GPT-3 to generate text like this. And some of the boxes were blacked out because, some of the statements are just too egregious to even display. Next slide, please. Yeah, so I think if you take a step back and you think about my presentation, a lot of it was I was just talking about the cool projects that I've worked on. And, that's just kind of how I was oriented as a person. I'm not particularly good at math. I got a B in stats and, that wasn't a good indicator of my statistics. But really what happened, what it also ignited was that I was just, at the time in high school, I was just playing a lot of video games and hanging out with my friends. And I stumbled across this thing on Kaggle, which someone took this huge database of FIFA 18 player ratings. And this guy created some model that discovered and predicted for the next generation of superstars, right? So it took a bunch of stats like pace, power, all these things, and came out with a list of players. And, I used that information and I, did really well in I don't know if you guys know what FIFA fantasy is, but FIFA draft. And so essentially this opened my eyes to, wow, all these cool projects on Kaggle. And then I kind of looked at this, super high-end, high applications of ML. And then I was like, yeah, I want to learn how to do that. And then so I started from ground zero. So it wasn't really the traditional route of, being very interested in math and and stats and then kind of build my way to ML, I kind of just looked at these cool projects that were out there and started to learn from there. And so something I would encourage high school or anyone for that matter is just to go on Kaggle or search up any machine learning projects, and you can just look at the things that they're producing without even needing to understand the code or math behind it, and just look at the things that people are making. And I find truly fascinating. Next slide, please. Yeah, so just to kind of wrap my presentation up, I want to emphasize that data science isn't like a field, you know, it's a tool that helps people find solutions that otherwise wouldn't be visible to them. And so, and there are tons of applications of data science, whether that be in like anthropology, archaeology, you know, English, to math, to business, you know, any field you can think about, there are new tools that data science is, you know, paving the way for these things to happen. Like, for example, I think this is a cool example in BERT. What happens that, you know, they trained it on some billions of texts, and what someone did was that it trained it on all this like old fossil, some super old language that only a few historians would know. And they passed in like all these cool and old fossils and read in all this stuff and had BERT classify what certain fossils meant, right? So instead of having a person sort through them, these fossils one by one and reading them and trying to understand it, they were able to automate that whole process with, you know, machine learning. And just, I thought that was also really cool. And so, and then in the picture, that's Seoul, and that's my next step after I've concluded my internship here at Verify. And I'm just gonna go explore and, you know, uptake some new projects with my friends that are going with me, and hopefully do something in machine learning. Yep, and yep, thanks for listening to my presentation. I hope you guys enjoyed my story and maybe learned a little bit more about machine learning and NLP, spark some interest. And if you have any questions, please ask me about anything.
Thank you, Ethan. That was fantastic, very inspiring. And in fact, I think I'm inspired to go back and do a PhD based on your talk and Ronilo's talk. So that brings me to the first question. You mentioned in your first slide, that you have no plans for doing a master's. I know it's a personal question, but perhaps you want to address that?
Yeah, you know, school and academics has never been my strong suit. You know, I've never really enjoyed taking like English composition writing or statistics classes or calculus classes. And I knew that in the society we kind of live in, going to an undergrad is kind of necessary, but post-grad, I at least don't have to go in immediately. And so I kind of plan to take, you know, the next 6 months and go to Seoul and kind of explore, learn new things, learn about new culture, maybe apply machine learning or data science in that, and, you know, take it from there. But no, yeah, I don't rule out post-grad for me personally. And also I'm sure Ronilo could talk about all the pros about going to grad school too.
Thank you. Thank you for that very candid answer. So we have Sohail. Sohail, can you please unmute?
Can you hear me?
Yeah. Hi,
All right. Hello. I guess I'll introduce myself quickly.
Please.
So I'm also a high school student. I'm from Ontario. And like a lot of you guys, I got interested into like knowing how I can learn about machine learning. So I just learned how to code, and through some personal connections, I was able to get in contact with Sandeep. And he actually offered me a mentorship at Verify. So like this summer, I've been able to work alongside Ethan, Ronilo, and Sandeep. I've been able to like join on their weekly syncs. I've learned a ton about like how it works, how like their tech actually works. But I think the most valuable thing I've gotten from this like experience so far is being able to actually like apply it and like actually like write code, create things. So that's been super valuable for me. And my question for, I guess, Ronilo and Ethan is, like, outside of school, let's say I want to get started on learning about machine learning, like on my own. There's a lot of things out there. Do you guys have any like specific resources you'd recommend?
Uh, so I don't know if everybody agrees with me, but I prefer to learn from books. I'm not like an auditory learner that can learn from lectures. So I like the book by T. Hasty, Elements of Statistical Learning. This is what I used to learn ML when I first started. That's my recommendation.
Thank you. Ethan?
Yeah, I'm kind of the opposite to Ranillo, and so I would recommend um, Kaggle is an amazing resource and place where you can look at, cool application and try apply that to something you're interested in. That's kind of the biggest. And then once you're doing that and you don't understand certain concepts, then for sure Google it. Coursera and Udacity have great learning tools to teach you about like basic things that you would eventually need to know and understand.